Alright, welcome back to another video on my channel, math_exe, and today we're going to solve this ratio type question, which looks innocent at first, but it looks pretty devastating if you look into it more. So given 4 consecutive multiples, I will explain that a bit later, of a number b, or a1, a2, a3, and a4. And what I mean by consecutive multiples, I mean like so. So given you have your b value too. And this is just an example, this is not just the answer, so yeah. So as you know, the multiples of 2 are 2, 4, 6, 8, 10, 12, and so on. What it means by consecutive is you take some group of numbers like so. So I have 2, 4, 6, 8. Those are consecutive multiples. And notice their positions, or I would say their order, their 1, 2, 3, and 4, where these numbers represent the position of its multiple. So the first multiple of 2 is just 2, second multiple of 2 is 4, and so on. And you can also take different groups from this set that I gave you. So for example, you can just take 6, 8, 10, and 12. This is also a consecutive multiple, a group of consecutive multiple, I would say. So notice the orders are 3, 4, 5, and 6, and these are consecutive orders. So as long as you have consecutive orders of multiples, there are consecutive multiples. So yeah, that's my brief explanation of what a consecutive multiple is in this problem. Okay, so for the first part, we're going to find the ratio of a1 to a3, and it's also given that the ratio of a2 to a4 is 7 to 8. And for the second part, given that a4 minus a1 is 12, we need to find b. Now it looks like we're not given enough clues for this one, but we can just set up a trick that I'm going to show you. So given our consecutive multiples, so a1, a2, a3, a4, and notice they show you consecutive multiples have consecutive orders. So for example, this is, we'll just call it x, where x is a positive integer. So we can call this position x, this is position x plus 1, this is position x plus 2, and this is position x plus 3. And what we'll do next is we can just rewrite each of these terms as follows. So we have our x, and then we can just multiply b, because the order of the multiple times what number it is, in this case b, as our, I would say, multiple thingy, will give us a1. So like I shown you earlier, 2. So notice the first, second, third, fourth order. So if we multiply this by this, we get this, and this, we get this, and so on. So yeah, so a multiple is given if as the number you are choosing times the position of the multiple itself, or I would say the order at least. Oops. Okay, so next we can just rewrite this again. So we have x plus 1 in the parentheses b, and then next we can have x plus 2 b, and then finally x plus 3 b. Alright, and notice this term right here is just a1, this term right here is just a2, this term right here is a3, this term right here is a4. Now we can solve for x given our given which is a2 to a4 is 7 to 8. Now we can rewrite this as a fraction form. I will show you later. So we have a2 over a4 is equal to 7 over 8. And notice we can just substitute this and right here, this and this. So we can have x plus 1 b all over x plus 3 b. And notice the b and b will cancel nicely. And remember, this is always equal to 7 over 8. And when you're doing a situation like this, you can always cross multiply. So we have 8 multiplied by x plus 1. 8 multiplied by x plus 1 is equal to 7 multiplied by x plus 3. And then we can just expand things out a bit. So we have 8x plus 8 is equal to 7x plus 7 times 3 is 21. And then we can just subtract both sides by 7x. This is just simple algebra stuff. So notice negative 7x and 7x will cancel. We have x plus 8 is equal to 21. Subtracting 8 from both sides, we can get that our final answer x is equal to 21 minus 8, which is 13. And with this given information, we can just find the fixed value of a1 to a3. So we can just conclude that a1, I'll just rewrite this as a1 to a3 is equal to, note our notation right here. We have a1 right here and we have a3 right here. So we have xb over, or I would say xb to x plus 2 in the parentheses times b. So we have xb to x plus 2b. Notice the b and b cancel once again, and we can just substitute our given values right here. So we're left with 13 to 13 plus 2 is just 15, and this is our answer for A part. Now for B part, we're given A4 minus A1 is 12. So we can just substitute our notations right here. So we write A4 as x plus 3b, and we already know what x is, so we're good to go. And then we have A1 right here. So we have A4 minus A1 is 12. And then we can just rewrite things out a bit. X plus 3 multiplied by b minus xb equals 12. And okay, we can just factor the b out and let's see what we get. So we have b and we have x plus 3. This is what is left after we factor out the b. And then what's left after factoring b out of this term, we got just negative x. And notice our x and negative x will cancel, so we have 12. And I'll just move this right here. We have 3b is equal to 12. And we can just divide 3 on both sides, so we can get that our final answer for our b is 4. There we go. Okay, so that's it for this video, and hopefully you guys enjoy this problem and this video. Please subscribe for more because I'll upload more videos in the future. And as always, goodbye.